What's going on, guys? Assalamu alaikum. Welcome to Amigoscode. In this Java course, I'm going to teach you the foundation of this awesome programming language called Java. Java is a programming language which is used by companies such as Google, Facebook, Twitter, Spotify, AWS, and a bunch of other startups to power their backend systems. It's a language which will stay here for a long time and taught at universities, boot camps.
Why is my nose so shiny? Like,
And people use Java because Java is a mature language. It has lots of libraries and packages which are very standardized, and it has an amazing community. Java is a language which is not going to die anytime soon, and you should know Java because it will open the doors to learn many other programming languages. If you're new to my channel, literally just take 1 second and smash the like button. Also subscribe. Literally subscribe so I can keep on providing content and courses like these. Without further ado, let's start this crash course. Okie dokie. Let's go ahead and understand what exactly is Java. Java is an object-oriented programming language, meaning that you can take anything that you want, literally anything. So let's just take, for example, this cup in here and this remote in here. So we can turn everything into an object. So programs in Java, they are based off objects. So you create a bunch of objects and then you connect those objects together, right? So we try to model something in the real world. And also things in software, as you see later in this course, but basically everything is an object. For example, a sequence of characters is an object, and later you'll learn about strings and all the other classes, for example, working with dates as well, but you'll see how everything is an object. Java was created by James Gosling in 1995, so it's been some time really. And you might be thinking, right, so Java is quite old. Yes, indeed, it's quite old, but it's used throughout the industry if you want to build enterprise applications. So the cool thing about Java is that it's established already. It's a language which is established. There's already patterns, and it's a safe language if you want to build large scale applications. So Java is a must. Java is a must. There's a famous quote that says that Java runs on 3 billion devices, and that is, I think, I'm not too sure how accurate they are, but you can see that Java is popular. So you'll see the uses of Java in a second, but Java is very similar to C++. So if you've done some C++ before, Java will be very easy. This is because, with Java, you don't have to manage the memory. So all of that is done by the language itself. Whereas with C++, you have to, allocate, deallocate memory, and, it can be a little bit challenging for beginners to do this, right? Also, I think it's very important to stress out that C++, so these are the mothers of all languages, but I also add in Java after C++, because once you learn Java, you'll see that the rest of the languages, so you take Python, you take JavaScript, you take Golang, you take many other languages, you'll see some similarities in it, some similarities. And with Java, you learn a bunch of constructs that when you move to those languages, you'll be like, wow, this is a piece of cake. So Java is a must. So this is what they teach at universities. And yeah, so this is why I'm teaching you, because I want you to learn Java so that you go off and find a job, and throughout your career you'll realize that a language is just a tool, and Java, it's the perfect language for beginners. And finally, Java is very popular, so you can build backend applications, you can build front-end applications. I think still maybe a little bit of mobile apps today, but now all of that is shifting to Kotlin. And yeah, so Java is very popular. Lots of companies are hiring Java developers. So it's a language that you should have under your toolbox. This is all for now. Catch me on the next one. So before we continue any further, I just want to say that this course is part of the brand new course which I've just released on my website. And it was a course that I did teach at a bootcamp for over a year. Many students of that course, they managed to go off and secure jobs. And yeah, so I was like, you know what, let me just take whatever I'm teaching to these students and make it available at a very cheap price, and also online, right? So if you want to watch the videos again and again and again, the way I teach, as if I was teaching for a bootcamp, it's there for you. Also, there's something called the Amigoscode textbook with a bunch of exercises and code examples that you can use alongside with the course. We also have a private Discord community where you can join. And if you have any questions or you're stuck or you want to suggest some ideas, we'll be there throughout the entire course, so you're not alone. Currently, there's a 20% off, so I'll definitely take advantage, as many people already did. And I'll say this is the right time for you to invest in yourself. You've seen how tech and programming is becoming very popular. And the sad thing is there's a bunch of jobs out there, but not enough engineers. So what are you waiting for? Let's get started. So what can you build with Java? Well, the list is huge, but let me show you some of the things that you'll most likely be doing. With Java, you can build mobile apps for Android. So even though now new applications are being built with Kotlin, which is another language, but you'll find that there's still some large applications which are still built with Java. But technically speaking, I think you're going to be reusing Kotlin if you write a brand new application, but nevertheless, Java is still used for Android. You can also build desktop applications using Java Swing, which is kind of also, if you ever went to the airport and you've seen these really ugly UIs, most likely it's Java Swing. So JavaFX is yet another way that you can build desktop applications with a better UI, but I think you'll see majority of all the applications are using Java Swing. With Java, you can build enterprise applications. So let's say that you want to build, for example, a bank. You can build a bank with Java. So here we're talking big, large scale applications. You can pretty much think of any idea that you want to build and you can use Java. If you didn't know, Java was used to build Minecraft. So here from Wikipedia, Minecraft is a sandbox game developed by Mojang. I'm not sure if I'm pronouncing that name correctly. The game was created by Marcus Notch Pearson in the Java programming language. So this was like back in the days, and you can see what a programming language is basically. But Java was used to build the initial implementation of Minecraft. Nowadays, I'm not sure what they use, but it's a popular game. You can also build cloud-based applications. So if you learn about the cloud later, AWS, Azure, Google Cloud, you can build cloud-based applications such as serverless applications and other types of applications using Java. Also, web applications. So the Java language is so cool because you can actually build an entire web application. So backend, front end, everything using Java, to be honest, right? But I'll show you what is the best approach for you to build applications. But you can see that you can actually build a lot with Java. So there are more other things that you can absolutely build with Java, but these are some of the things that you'll be developing with Java. So you saw some of the things that you can actually build with Java, but let me tell you with Java what you're going to be building most of the times. And this is the beauty of Java, really. So Java is a language mainly for the backend. So the business logic, so the brains, right? And we'll talk about more front end, back end, and whatnot. But front end is what the user sees. So the buttons, um, the color, the interaction that the user has, for example, on a web page. And the back end is the actual business logic. So it's actually the brain. So you don't see that. But for example, if you try and buy, for example, a mobile phone and you don't have enough credit, right? So that logic of saying, right, so you don't have enough credit, your card is now declined. So all of that is in the backend. So Java is a language used most of the times for the backend. If you try to build, for example, UIs, user interfaces with Java, I don't recommend you to do that because there are other options. JavaScript is the most used programming language for UI, and then you have the frameworks React, Vue, Angular, and others, right? But Java is used mainly for the back end. Don't even try games as well. So for games back in the days, yes, but games you might want to try, for example, C Sharp. And also if you're building, for example, small applications like command line applications and whatnot, I would, try and stay away from using Java. So Java is mainly for the backend, where later you'll see with Spring Boot. So upon completion of this course, you'll see how we're going to build a RESTful API where you've got a client. So these could be, you using a web application on a web browser, and then you have the client sending a request to the backend, and then all of this. So all of this here is where Java kicks in, right? So Java takes a request, then you have the business layer. This is the n-tier architecture, and you'll learn all of this later. But basically here you kind of make your business decisions, and then you have the DAO layer where you can actually store data against any database of choice, whether it's a relational database, a file, or a list, or a NoSQL database. And then you actually send a response back to the client. So the client sends a request, and then the server, right? So the API sends a response. So all of this is stuff that you don't see. So this is the back end, and Java, it's mainly used for the back end. I'm not going to teach you Java for Swing, nor Java FX, nor games and whatnot. I'm going to teach you what Java these days is used for, which is to build enterprise applications. And in fact, let me show you what I mean. I used to work for this company here called Starling Bank, and I actually joined, early stages when it was actually a startup, about 50 or maybe 30 engineers, and I've helped him to build majority of, the backend systems, some UI as well with React and JavaScript. But they are a very big company now, right? So you can see that, with Java, they went and they built a bank. This is a bank which runs just on your phone. And it's incredible to see that, with Java, if you look at the code base, there's thousands and thousands and thousands, or actually over millions of lines of code just with Java, right? So if you want to build enterprise application with Java, you can see that, Starling Bank, they've done it. There are many other startups that use Java because, the demand for Java engineers is quite high. There's many engineers that know Java. And yeah, so whether it's a big or small companies, they usually tend to use Java because it's very easy, and there's lots of people to hire. And whereas if, for example, you were to say, right, so now I want to use Golang, for example, to build an application. Not many people know Golang or experts in Golang, because Golang, it's a language which hasn't been around for many years, whereas Java, it's been around for many years. The patterns are already established, the tools are already there. This is why people use Java. So it's very popular among startup. And actually, one application which actually you might be surprised if you know IntelliJ, and this is what we're going to be using throughout this course. IntelliJ is actually built with Java. So this is the best IDE for writing Java and other languages, basically. But it's the best IDE for the JVM, IntelliJ, and all of this. So the UI, so even the UI is actually built with Java Swing, and it's amazing how, I don't even know how they done it, but it's amazing. So IntelliJ, it's amazing, and that's what you're going to be using throughout this course. I wouldn't recommend you to go and build an IDE with Java, because it's going to be costly to you. And yeah, I don't know. I just feel like it takes a lot of effort and guts to actually build something like this with Java. Cool. So this is all for now. Catch me on the next one. Okie dokie. Now we are almost to a point where we're going to be able to write our very first Java program. But first, how do we even write Java code? So how do we basically write code for the Java language? Well, we can pretty much use any text editor, to be honest. So we could use Notepad++, we could use Sublime, Microsoft Word if you wanted to, but don't do that. Yeah. So when it comes to Java, there are a couple of IDEs and text editors that you should really be using. So one of them is Eclipse. So when I started back in the days, long time ago, Eclipse was the most popular IDE for writing Java code. But since time has moved on, IntelliJ Idea now is the preferred choice for writing Java code. So the integration that it has to offer, the tools, they are amazing. And it's the one that I recommend to everybody. And people, even when they switch from Eclipse to IntelliJ, it's like night and day, trust me. Then we also have Visual Studio Code. Now, Visual Studio Code is kind of nice as a text editor, and it doesn't come with, all the support that Eclipse and IntelliJ come right out of the box, because you kind of have to install a bunch of plugins here and there. Now, you could use Visual Studio Code, but you need to know what you're going to install in order to make it a fully fledged IDE, because Visual Studio on its own is just a text editor. So for this course, we're going to use IntelliJ Idea. So as I said, the most popular IDE for Java is IntelliJ Idea, and this is by JetBrains. So JetBrains is a company, and they not only have IntelliJ Idea, but they have a ton of other cool IDEs. Now for IntelliJ, there are two versions available. We've got the Community Edition, so this is free. And they have the Ultimate Edition. So the Ultimate Edition is really great once you start to build web applications with Spring Boot and connecting to databases and whatnot, because it has all of that integration in the IDE itself. But for this course, we're going to use the Community Edition, which is absolutely free, and it has everything that we need in order to complete this course. But then later, we're going to switch to Ultimate. And luckily for you, actually, I've got some friends at JetBrains, and I do have a coupon code that you can redeem so that you can get Ultimate Edition for 3 months. If you also are a student, you can get Ultimate Edition for free, or if you're a teacher, if I'm not mistaken. Cool. So let's go ahead and download and install IntelliJ. Okie dokie. In here, I'm within the official webpage for jetbrains.com/idea. So this is the official page for IntelliJ. Now in here, it tells you why you should use IntelliJ. So enjoy productive Java. And you can see that it's quite slick, to be honest. The UI, if I scroll down, it gives you a bunch of integrations, framework specific assistance, productivity boosters, so you can automate stuff. And you can see that it's kind of cool. And in here, what people say about IntelliJ. Also the companies, all the new features in here, so on and so forth. Now, IntelliJ right here, it's mainly for Java developers. And this is only true when you use the community edition. So if I click on download from here or here, so you'll see that there are two versions. So the Ultimate Edition or Community. So the Community Edition is for JVM and Android development. So this is what I've just said. And then you have Ultimate for web and enterprise development. And you can see the differences in here. So the Ultimate right here supports Java, Kotlin, Groovy, Scala. And there's also a bunch of plugins that you can install. For example, if you are into Go development, you can install a plugin for Go or Python, so on and so forth. But here you can see the features which are common to both IntelliJ Ultimate as well as the Community Edition. Now, the Ultimate, where it really shines is, for example, if you are working with Spring, Jakarta EE, Java EE, Micronaut, Quarkus, and other frameworks. Also, it gives you an HTTP client that you can test your REST APIs. And then here it supports JavaScript. And then in here it has support for JavaScript, TypeScript, HTML, CSS, Node.js, Angular, React, Vue, and I believe there's some other integrations as well. This one is kind of cool, database tool and SQL. So you have a SQL GUI client within your IDE, which is kind of nice. And then remote development and collaborative development. And I think for the Community Edition, it allows hosts up to 3 guests and sessions length up to 30 minutes. So I will show you this later on, but it's kind of cool. So if you're working within a team and you want to do some pair programming, this is a really good feature that you can use from within IntelliJ. So this is pretty much IntelliJ. And I don't think I did mention, but for the Ultimate version, you have to pay. And it comes with 30-day free trial. And to be honest, I think, in my opinion, it's really worth it because as a professional software engineer, I've been using IntelliJ for many years now. And it's one of those ideas that, yes, you definitely have to have it if you are serious about software development and if you are serious when it comes to increase your productivity. Also, there is the Community Edition. And to be fair, I've used the Community Edition for many years before I actually made the switch to Ultimate Edition. So I would say start with the Community and then try Ultimate. But once you learn Community, then everything will apply to Ultimate. And as you saw, you'll just get a bunch of more features, especially if you're working with Spring and you're doing lots of database work, then it's really worth it. And especially if you are one of those developers that really like to have one IDE for all of their development, then Ultimate, it's a no-brainer. But if you, for example, like to have maybe IntelliJ just for the backend and then VS Code for the front end and any other type of work, then you should go with Community. But as time progresses, you kind of just want to stick with one IDE because it's all about increasing productivity. Once you learn this IDE well enough, you'll see that it's a game changer. Now, you can download IntelliJ for Windows, Mac OS, and Linux by clicking these buttons in here. But this is not the best way for you to install IntelliJ, and instead you should use Toolbox. To install Toolbox, click on Developer Tools, and in here you should see Plugin and Services. Click on Toolbox App, and in here you can see that Toolbox allows you to manage your IDEs. So it's available for Intel, Mac OS, as well as Linux. So download and install according to your operating system. So for me, I'm on Mac OS Apple Silicon. I'm going to save, and there we go. Now if I open up the downloads folder, and in here let me just open up this DMG file, and to install just take this and drag it inside of applications, and job done. I can close that and then eject, and now to open it up just search for Toolbox. There we go, and then open. And I'm going to disable notifications and have a look. Now Toolbox is open and we can install all the plugins through this app. So if you want to upgrade, downgrade, and add some configuration for your IDEs, this is the best way of you doing it. So you can see the list of all the IDEs in here. Now the one that we are interested is IntelliJ Idea Community Edition. Now I do recommend to start off with this one right here, so the Ultimate, because it gives you all the tools for pretty much every single language out there. And for now, what we're going to do is start off with the community, and then I'll switch to Ultimate. So not everyone will be able to afford the Ultimate, so let's just start with the Community Edition because it has a lot of similarities, and once you know Community Edition, then Ultimate will be almost the same thing but with extra features. Also, what I didn't tell you is that you can basically, if I click on this clog in here, settings, if you want, you can create a JetBrains account through here, and then you can log in so that it registers your settings and all the IDs that you have. So if you switch computers, then everything is synced up. So for now, I'm not going to do this, and I'll do that later when we install IntelliJ Ultimate. So let me go back to Tools and then install IntelliJ Idea Community Edition. So this will take a while. So I'm just going to fast forward things so you don't have to wait. So there we go. And now I can open up IntelliJ Community Edition. So just give it a second. And in here, I'm not going to send anything for now. And there we go. So you can see that I can actually import some configuration if I have, but in here, I'm not going to do anything. And beautiful stuff. And we have successfully installed IntelliJ. Okie dokie. So as we begin this course, we're going to start from the basics. So what I want you to do is take your time, don't rush it. Literally take your time and follow step by step. If you have any questions or anything is unclear, do let me know, because I want to make sure that you gain the most out of this course. So as the course progresses and things become more difficult, don't you worry again, because we have a special Discord group just for this course where we can ask questions. And also you can ask me questions if you are stuck. But sit back, relax, take your time, and if you don't understand something first time, just watch the videos again and again and again until it makes fully sense. I'm also going to be giving you exercises, so don't you worry. So we're going to start off really small, really simple, but then as we progress through this course, it will become more challenging. But that is the whole point of this course, because I want you to learn and go off and secure jobs. And if this is a course which you are doing as part of your new job, or maybe an intern or a grad scheme, you will be fine. Trust me. Cool. I'm super excited. Let's get started. So within IntelliJ, let's go ahead and create a new project and make sure to pick Java. So you can see that there are other project types, but in here, let's pick a Java project. Then for the SDK in here, what I want to do, if for you, it says that there is none available, or if it's red, go ahead and click on it and then download JDK. And here you can download a specific version. So currently 17 is the latest as I speak, and is the one that has the long-term support as well. So I think it's 17 as well as 11 and 1.8. These are long-term support. So 17 in here. So if you see 18, for example, what I want you to do is you can pick any of these versions because everything will work. But to make sure that everything works smoothly, just follow along with the same version. So 17. Then the vendor, I'm going to leave the default, but you can have other vendors such as Eclipse, IBM, so on and so forth. So I'm just going to stick with Oracle, Open JDK, and then here I'm going to say download. But obviously for me, it's already installed. So let me just cancel and then next. And you can see that we can create a project from template, i.e. a command line application. And for now, let's just tick this box in here. And you can see it says simple Java application that includes a class with main method. So next, and then in here, you can give it a project name. So you could maybe just say Java or learning Java or your name, anything really. So here, let's just say, for example, Java. And for the base package name in here, com dot, and then change this to your name or company. So here I'm going to say Amigos and then code and then finish. And there we go. At this point, you can see that on this side, we have the project window. So if I expand it, you can see that we have a couple of folders. So we have idea. So this is mainly for IntelliJ. So this is where all the configuration is for IntelliJ. Then we have SRC. So this is where all your Java code should be. If I open this up, you can see that we have com.amigoscode. So this is the base package that we've just defined before. And then here we have main. So main, so this is the name of the class that we have. On this side, this is where we write our Java code. And basically the rest is IntelliJ. So here, if I collapse this, you can see that this now takes the entire screen. If I want to put it back, I just press again. And sometimes you might not see none of these panels. So it's because of this button. So here you can see that I can hide all of that. And if I put it back, you can see that all the panels come up, and there we go. Next, let's go ahead and write our very first Java program together. In here, we have this class called main. And there's a bunch of things in here which I'm going to make sure that you fully understand the meaning. For example, package, public class, public static void, main, and then this, write your code here, so on and so forth. But for now, I just want to make sure that you can basically run your very first Java program. So here, let's type together after line 6, just say system dot and then out dot and then print ln. At this point, I'm going to add double quotes. So double quotes. And then I'm going to say hello and then Java. And I'm going to add an emoji. And let me just select this one. So now, in order for us to run this code, you can see that we have few play buttons. So we have one play button in here, another one here, another one here. And if you look carefully here, so this class has also a play button, which means that you can right click and then say run. Also, if I right click on this side, I can just say run. So there's a couple of ways that we can run our Java code. So let me just run it from here, run main, and check this out. So here we have hello Java and then our emoji. So this is pretty much your very first Java program. Also, if I hide this and let me duplicate this line, and instead of saying hello Java, I'm going to say 10 and then plus and then 10. Let's just run this once more. And there we go. So you can see that we have hello Java and then 20. So this is the result of 10 plus 10. Now this right here allows us to print to the console. So this is our console in here. So as I teach you and run all of the examples, the output will be in this console, which is accessible on this tab right here. So the run tab. So I can click on it and you can see that it pops up. I just want to make sure that you can run your very first Java program without no issues. If you have any questions on running your code, please do let me know. Otherwise, catch me on the next video. So let me open up the terminal within IntelliJ, and in here I'm inside of Java. So this folder is the exact same thing as this one. And what I want to do is to cd into src. Now within src, what I'm going to say is Java C. So this basically is using the Java compiler, and I want to compile the class which lives under com/Amigoscode / and then we have main.java. So even though you don't see a .java file extension in here, but here, have a look, main.java. So this is the file that we are working with. Now the .java extension, this is what you and we write. So this is what we understand. And in order for the JVM to run our code, it needs the bytecode. So here, if I basically press enter, and you should see that now in a second, there is a main.class. Now let's invoke the JVM, i.e. we want to run this code by saying Java, and then you can say com/Amigoscode / and then main. And in here, you don't need the .class extension. So it just knows that you want to run your class. If I press enter, have a look. This is the exact same thing that we did before. Also, instead of saying /, you can say dot. So dot in here. So com.amigoscode.main, just like that. And this works because this is the fully qualified name for this class right here, because it lives under this package, com.amigoscode, and more on packages later. So if I run this, you can see that this also works. Now, this is it. It's super easy. What IntelliJ does is, so if I basically run this once more, have a look. So when we press the play button, have a look. So here, the command which IntelliJ uses is, so basically it finds the executable, so Java right here, and basically it passes some arguments. So here, -Java agent, and if I scroll all the way to the right, have a look, it says class path. So this is where to find all the classes when you run your Java code. And in here it says uses Amigoscode, idea project, Java out production, and then Java, right? So this right here is our project. And then it says, right, so under this class path, find the class com.amigoscode.main. So this is what we just did manually, but IntelliJ is doing that for us. Now the compiled classes are stored inside of the out folder. Have a look, out, production, Java, com, Amigoscode, and then main. So this is the class right here. So this is the class file which is compiled. If you have more classes in here, everything will be compiled into this out folder, so that IntelliJ can then invoke this command to run your application. Next, let me go ahead and show you how to view the bytecode. Another thing that I want to show you is that If, for example, we have any issues with our code, so let's say that we are missing a semicolon in here. Now you can see immediately IntelliJ is telling me that there is something wrong going on. So here, this is red, the package is also red, the project is red, this folder is also red, and also here it's red. So if I put my mouse in here, have a look, it says semicolon expected. Now what I want to show you is, if I try to run this, you can see that it failed to compile. So let me just delete this out folder for now and have a look. If I try and run this, so if I open up out folder, there is no classes inside of this folder because the compilation failed. So if we can compile, it means that we cannot run our code. So literally, if you have any issues with your code, you have to fix every single error that you have in order to compile your code. So here, if I add this back and then run it, you should see that now we should have main.class in here. So the same thing, if I just, let's say that I'm missing this opening bracket in here. So here, if I basically from the terminal, let's just open the terminal and let me clear the screen. I've just pressed the up arrow. I want to compile the Java file and have a look. It says that error, reach end of a file while parsing, and then you can see where it's telling you where the error is. So the same thing, if I try and run this through here, we should get reach end of a file while parsing. So this is something that you need to bear in mind, is that if you have any issues with your code, then it means that you cannot run it. So let's say that I also have a new and then class. So we haven't learned about classes, but let's just say that you have a class called foo in here. Now, if this class has also problems, so here, now you can see that there is an error, and even though the error is not present in this file called the main, so have a look, this file, everything is fine. But if I try to run it, have a look, it says that it failed to compile in here, and it says that this is expected. So here, what we are doing now is we are basically just fixing the compilation error. So here, I've just added that and it fails to compile. So if you want to just compile, so here, IntelliJ has this feature in this menu right here. So if you click on, I think it's build, and then have a look, you can build the project and it will basically try to compile, and the same thing, it just fails. So something to bear in mind is that if you have any errors in any of the other files, right? So if you don't have an error in main, but you have an error in some other file, then you need to fix all of those errors before you can compile your code, right? So you can only run your code if it has no errors. Now, when I mean errors, I mean syntax errors, right? So you saw, for example, if I say in here, let's just say, for example, 10 and then space 10. So this is not valid code, right? So this is not a valid code. Therefore, it will fail to compile and you won't get the bytecode for it. But if I basically have a plus in here, this is fine. If I try and run it, you can see that it works because no other file has any errors. So this process of fixing all of these errors, sometimes you'll hear people saying that I have to fix all of the compilation errors. So compilation error means that if there's a problem with your code, or you're missing, for example, a bracket or a comma, for example, and you can see that this is red. If I try to run the code, it doesn't compile in here, the build fails, and I need to fix all the compilation errors. So let me just fix one in here and off we go. So if I run this, we now fixed all the compilation errors and our program runs. Before we move any further, let me talk about this method right here, which is really, really important. So public, static, void, main, string args. Now, all of this might not make sense to you, and that's because I didn't explain, but hopefully by the end of this course, you will fully understand what all of this means. But for now, all I want you to be aware of is that public static void main, this is a method, and it's a very special method because this method is the main entry point for your Java program. So if you don't have a method called public static void main, then your code will not run. So have a look. If I basically change this from public to, let's just say remove that, you can see that now I cannot run my code. So I can right click, have a look. No way for me to run this code. Also from here, right click, no way to run this code. So if I say public, go back. So now you can see that I can run the code. So it's very important that you always have public static void main. So this method in here, and then whatever code that you have inside, it will be executed. So here, if we run this once more, you can see that we have hello Java. Now, later down this course, you'll understand how to structure your code correctly so that you can have multiple classes, so on and so forth. But for now, all I want you to know is that this is a very special method and it's the main entry point for your application. Now here, you can see that we have public class main. So this can be called anything. So here, if I rename this, so right click, refactor, and then rename, I can say, for example, foo right here, refactor. So this can be anything, literally any name. So if you have this method, then this will be the main entry point and the syntax should be exactly as it is in here. Public static void main, parenthesis, string, and then these square brackets and args. And you can have all of this code inside, and this is what's going to be executed. In here, you see public, static, void, public class, package. Don't worry, I want to teach you all of this in a second. Let me just press Command Z, and I want to have this class named as main. So this is a better name. So main basically means for the main class, which contains the main method. If you have any questions, please do let me know. Otherwise, let's move on. Let me walk you through about the Java syntax and how it works. So in here, have a look. Let's just start with this line. So here, package com.amigoscode, and then have a look. In here we have semicolon. Now every single line, so if it's not a method nor a class, it will end with semicolon. So here, semicolon, the same here, semicolon, and the same here, semicolon. If the semicolon is missing, have a look. You saw that this will fail to compile. Then in here, have a look, we have public class main and then curly brackets. Now IntelliJ has this really nice feature where we can basically toggle down. Have a look, I can toggle this. If I basically collapse this, have a look, I can see that. I think if I remove that, yes. Actually, it doesn't work for main. Basically, this opening curly bracket has a corresponding closing curly bracket. So there is actually a really nice plugin. So if I go to IntelliJ Idea, Preferences, and navigate to Plugins, and then I think it's the bracket, Rainbow Brackets. So let's just install that, and I'm going to restart my IDE, and you can see that it has 6 million downloads, by the way. So it's quite popular. There we go. My IntelliJ has restarted. And now we have rainbow brackets installed, and check this out. So if I close this, you can see that now this right here is yellow, right? So this is yellow. If I open this one up, have a look. This now is red. So this is basically easier for us to see all the matching brackets. So for example, if we have, so in here inside, if I say if, and then true, again, we're going to learn about if statements later, but now this time it's not going to be green, but instead it's going to be blue. So this is a nice plugin that I think you should use so that you understand which closing bracket belongs to its corresponding opening bracket. And when it comes to brackets, we have two types. We have curly brackets, which are these ones, so curly. And we also have these ones, which are square brackets in here. So let me just delete this if statement because we haven't touched if statements. And let me also close this because we haven't learned about if statements. But on brackets, so here, opening, closing. And within this right here is a method. So this is the method body in here. So within this method, this is the method body. Within this public class, so everything within it is the class body. Now it's very simple. You have curly brackets. For each one, you have a corresponding closing. For this course, we're going to be printing out lots of things to the console. And what I want to show you is a quick shortcut that we're going to use to speed up this line right here. So system.out.println here allows us to pass anything within it to be printed in our console. So if I run this right here, you should see that we have hello and then 20. Now, this is kind of long-winded, so I don't want to be typing here all the time. So system.out.println. So instead, let's together type SOUT. And you can see that we have a couple of live templates in here, but just pick the first one. So SOUT, enter, you can see that it gives us this shortcut in here. So if you hear me saying SOUT, I just mean printing out to the console. So this actually prints a new line. So if you don't pass anything, so here let's just say SOUT. So have a look at the output before. So hello Java 20. If I put a SOUT or system.out.println in between, it will give me a new line. So have a look. If I run this, you can see that now we have an empty line in here. So I just wanted to basically let you know about this awesome shortcut. And if you want to learn about IntelliJ and master it, because I think if you want to step up your game and be a pro at what you do, then you should know this IDE inside out. And knowing this IDE inside out is like having superpowers. Catch me on the next one. Also, within IntelliJ, have a look. Package, public class, public static void, and all of these are basically orange. So in Java, we have a bunch of these keywords which are used for the Java language, and they are known as reserved keywords, i.e. keywords which are used specifically for Java. So if we were to try to use these keywords for building our program, then we can't use them because they are only used for the Java language itself. So if I was to say, for example, here, string and then public, have a look, equals to, and then maybe this, right? So here you can see that immediately this is an error because public is a reserved keyword. But if I say publics, so publics is not, therefore we don't get an error. And let me see what the error says. So let me just try and run it and have a look. So Java, not a statement. So this is not a statement because this is a reserved keyword. The same with void. There we go. So this is a reserved keyword. So let me show you the list of all reserved keywords. And in fact, let me just delete this. And if I show you the list, so this list is actually taken from W3 schools. And have a look. We have abstract, assert, boolean, break, byte, case, catch, char, class. You've seen this one. Continue, const, do, double, else. And you can see a bunch of them. Exports, final, float, for, if, int, long, new, package, public. So you've seen public, requires, and you can see that it's a big list. But I would say no need to memorize all of these because you'll get exposed to majority of them throughout this course. Now that you know how to get up and running with Java, let's focus on the foundations for this awesome programming language. So Java, as I said, is one language that if you know it well enough, then the rest will be easy to follow. So the first thing I want to show you here is comments. So have a look in here, write your code here. So this is a comment that allows you to document your code. So this right here doesn't get executed, and it can be anything that you want. So here I can say, for example, foo bar, for example, and this is just a comment. So it allows me to basically just document a piece of code, and maybe I want to come back to it later so that I understand, or maybe I want to leave a comment for someone else, right? So this method does XYZ, or this variable is used for XYZ. So this is what comments are used for. Now in here, have a look. If we run this program, nothing happens because this right here is just a comment. It doesn't get executed. Now what happens if we basically just stick / in here and / in here? So if I run this, have a look, nothing is printed to the console. And this is because right here, we told Java that this should be a comment. And I said that if you put a comment, then everything that proceeds can be literally anything. So if I go back, Command Z in here a couple of times, and this is basically single line comments. If you want a multi-line comment, you can just basically, so in here, let me just put this same level as this. So this is a single line comment. So single line comment. And if you want a multi-line comment, you just say /*. And then if I press enter, have a look, we've got opening and then close. And this now is a multi-line and then comment. So you can see that it spans across multiple lines. And there's no limit really to how many lines you can have, but this is how you add a multi-line comment. So again, these are only used for documentation purpose, and they have no effect when you run your code. Let's go ahead and learn about variables. A variable allows us to store a value into a placeholder, which we can later use it. For example, if you want to store two numbers, you can store them into a variable and then add them together, and you can store the result of a back into yet another variable, and then you can print it out. So here, let's say that you want to store whole numbers. So what we are learning here is primitives. So primitives. So primitives allows us to store simple values. So here, let's say that I say int and then number and then 1 equals 2 and then 20. I can also store number 2. So int number 2 equals to 20. And if I want to, now I can basically perform addition on these two numbers. So if I print and then say number 1 plus number 2 in here, and if I run this, you should see that we have 40 in here. So a variable, so this is a variable. So this is a variable, yet another variable. We can actually take the result. So we can take this also in here. So let me just cut that. Say int result equals 2, and then number 1 plus number 2. And here I can print the result. So result, and this is the exact same thing. There we go, 40. Now let's just basically cover this. So here, int, this is the data type, this is the variable name, and this is the value. So you have to say equals and then the value, and always end it with semicolon. The same here, int number 2, 20, and then the same here. Now int, so this is a data type that allows us to store whole numbers. If you want to store decimal numbers, there's a data type for that. So maybe you want to store the value of pi, just say double and then pi equals to 3.14. There we go. If you want to store true or false, i.e. booleans, you could say boolean and then is and then adult, for example, equals to and then false. So in here, this only takes true or false. If I try and put a number, for example, 3, this doesn't work. So if I say true, and the same here, if I try to put a true value in here, this data type only allows us to store decimal numbers. The same with integers. So if I say 20.0, this doesn't work because an integer allows us to store whole numbers. If you also want to store in here a character, you can say char, and then maybe we want to store the letter A equals. So here I've just named the variable A, and the value will be single quotes and then any letter in here. So these variables in here, they are primitives, and primitives allows us to store simple values. Later we'll cover reference types, which allows us to store complex values. But for now, just know that if you want to store simple values, use primitives. So for example, numbers, whether a value which is true or false, or a single letter, or a decimal number, so on and so forth. Next, let me show you the difference between int, double, boolean, and the rest of the primitive data types. So primitives allows us to store simple values, i.e. whole numbers, decimal values, characters, and in here you can see the list of them. So boolean, byte, short, char, int, long, float, and double. Now, what is the difference between all of these? Well, the difference is that, for example, if you take double and float, so these allows us to store decimal values, but float allows us to store bigger numbers, therefore taking more space in memory. Let me show you the table. So have a look. So we have the type, the size, minimum, maximum, and there's an example in here. So byte in here, the minimum number that it can have is between -128 and 127. So within IntelliJ, if I create a byte variable, so byte, and I'm going to say n equals to 127, have a look. So this works, but if I say 128, it doesn't work. So I cannot fit a number bigger than 128 into the byte variable. So here, the next data type that allows me to store whole numbers bigger than 128 is a short, right here. So short, and short. So if I show you, have a look, minus 32,000 plus 32,000. So as soon as I say a number, for example, 40,000, for example, so 4000, I cannot store a number bigger than 42,000, or actually just 33, right? So I think it was 32,700, I think. But if I say 33, I cannot store right here. And the next data type that allows me to store whole numbers bigger than this is int. So have a look, int. So int now allows me to store really big numbers. Also, if you want to store numbers bigger than this, so this is the maximum here, you can use long. So these allows us to store, so byte, short, int, and long allows us to store whole numbers. Then we have float and double for decimal numbers, and you can see the minimum right here and the max as well for both sides. And then we have character and boolean. So boolean allows us to store true or false values, nothing else. Now, generally speaking, you will never use byte nor short, and most likely int all the time. If you need bigger numbers, then this right here, you should use long, and then double. So float or double for decimals, characters, and boolean. And the reason why you've got these data types in here is because before we used to have a constraint on the memory RAM. So people used to code these programs, and because they didn't have enough storage on the RAM, then they had to use these data types. But these days, this is not an issue. So in my case, for example, my RAM, so I've got the Mac M1 Pro, and I've got 32 gigs of RAM, which is not an issue. And have a look at the size in here. So this is bits. So 8 bits is 0.125 bytes. So this is literally nothing. So integers right here, so 32 bits is 4 bytes. And again, this is literally nothing. And if I show you the conversion, and in this website, it gives us the computer storage unit, so smallest to largest, bit is an 1/8 of a byte. So have a look, byte, 1 byte right here, a single byte stores 8 bits. So this is what I was showing you in that chart. So a kilobyte equals to 1,000 bytes, megabyte 1 million bytes, gigabyte 1 billion bytes, and then we have terabyte, which is 1 trillion, so on and so forth. So in my case, I have 32 gigabytes, i.e. 32 billion bytes. So if I have a bunch of these variables, for example, an integer, then basically you can see that these days memory, it's not a problem. But these are primitive data types, and they allow us to store simple values. Let's say that we have this integer variable right here called amount. Now, the question to you is, can you tell me what number is this? And you have 2 seconds. Well, your time just elapsed. Now, sometimes when you want to represent really big numbers, it's really good for you to use underscores to help you recognize the number, especially if it's a big number. So in here, you kind of have to know, okay, so 3 zeros here, another 3 zeros here, yet another 3 zeros, and it's 1 billion. So what we can do instead is we can use underscores. So here, if I say underscore, and then underscore in here, and underscore in here. Now have a look. Now this number is much easier for you to read. Now underscores, it doesn't really actually add underscores, but it's more for readability. So if I was to print the variable called amount and then run it, you can see that it still prints the number without underscores. So this also works for decimal numbers. So here, if I change this from an integer to a double, so double, and in here I can say .00, and you can see that it still works. So if I run this, you can see that this is the double representation. So because this is a very big number, that's why we get it like this. But for example, if I was to, let's just say 1000, so in here, just 1000, just like that. And let's just say 31, for example. Have a look. So now we do get the number properly formatted. You can see that this is much better to read, and it's what you should use when you want to represent big numbers. Let me teach you about the arithmetic operators that Java has to offer. So they allow us to perform common mathematical operations such as addition, subtraction, multiplication, division, so on and so forth. So if you have 2 numbers, so here let's just say int and then number 1 equals to and then 10, and let's also have number 2, so int number 2 in here, and I'm going to touch on naming these variables in a second, but for now, just name them as this. And let's also say that this is 20. If I want to add these numbers together, let me just print to the console. I can say number 1 and then plus number and then 2. If I want to subtract these numbers, I just say minus. If I want to multiply these numbers, I can say times. If I want to divide, I can just say divide. So this is the divide symbol in here. So 10 divided by 20. And let's just change this number so that we get a proper result. So let's just say 2, for example. And in fact, let me just make 3 in here. And finally, what I want to show you is the modulus operator. So here, let me just duplicate this. And in here, I can say modulus. So this is the percent sign. So this is saying how many times number 2 can go into number 1, and then the remainder is basically the result. So what is left? So 3 can go into 10 3 times, and the remainder is 1. If I run this in here, you can see that I get 13, 7, 30, 3, and then 1. Now, if you have done any maths since primary school and whatnot, you probably know about BODMAS. So BODMAS, which means, so let me just put this here. So brackets, order, and let me just put this on a new line in here. So have a look. You've got brackets, order, division, multiplication, addition, and subtraction. So if, for example, in here, say here, SOUT, so here I can have brackets, and then I can say 2 plus 2 times, and then brackets, 3 divided by 1, and then I can say times, and then 2, for example, right? So here I'm using multiplication, but this could be any sign. So first will be this, then this, and then the result of it. So 2 plus 2, 4. 3 divided by 1 is 3. So 4 times 3, 12, times 2, 24. So if I run it, hopefully, there we go, 24. So you can see that the BODMAS rule does apply. So this is pretty much it. Next, I want to show you the plus plus and minus minus operators. In here, let's say that we want to increment this number right here by 1. We could do the following. We could say int, and then increment equals 2, and then number. So we're taking the value of number, and then plus, and then 1. If I want to decrement, I could just do the same, but say decrement, and then minus, and then 1. If I print both numbers, so SOUT increment and decrement, and then run this, you can see that we have 1 and then minus 1. So basically we started off with 0, 0 plus 1, 1, and then if we want to decrement 0 minus 1, it's minus 1 in here. Now there is a shorthand for it, and that is using the plus plus as well as the minus minus operators. So the way they work is as follows. So here, let me just comment this out to you so that you have it for reference. So let me just indent first, and in here I'm just going to add a comment. So / and let's just add a closing in here. So the way it works is, so if I say SOUT in here, so I'm not going to store the value into the variable itself, but instead I can say number and then plus plus. Now if I run this, have a look, this gives us 0 in here, and what this is saying is return the value and then increment by 1, which means that if I say SOUT and then number, run this, have a look, we have 0 and then 1. So this is saying return the value and then increment by 1. So by the time we print the value, it will be 0 and then increments for the next use. The next use is here, line number 7, and the value is 1. If you want, you can have plus plus before the number. So here, if I just duplicate this in here, and let me paste this, and let's just say in here int and then number 2, so you can have both references. So here I'm going to say number 2, just like that. Now, so this should be 0. So here, if I want to increment immediately and then return the number, this is how you do it. So basically here it says increment and then return the value of it. So by the time it does this, this will be 1, returns the value. So when we print, will be 1, and the next time will also be 1. If I run this, have a look. So we have 1 and 1. So this is the increment operator. Similarly, we have the decrement operator. Again, let me just add a comment, / and then star. And let me just push this in here, just like that. And I'm going to say increment operator ++. And let's basically take the exact same thing and we're going to do for decrement. So decrement is as follows. So if I basically duplicate this and then just paste it here and uncomment this, there we go, and then remove this. So this works as follows. So here I say, instead of ++, I say -. So this is saying now return the value and then decrement. So this will be 0. And then the next time that it prints the number will be -1. The same, if you want to decrement and then return, you say - before. So if I run this, you can see that we have 0, -1, -1, and then -1. So this is pretty much it. So let me just add a comment in here as well, so you have it for reference. So this is the decrement. So decrement operator, and this is using -. If you have any questions, please do let me know. But keep this in mind because later we're going to use this with loops. That's all for now. Catch me on the next one. When working with Java, we can use these comparison operators to perform comparison on primitives. This sign right here is the less sign, less or equal, greater, greater or equal, equals, not equals. So this is exclamation mark and then equal. So in here, if I print to the console, so let's just take a number. So 10, I can say whether 10 is greater than 10. I can duplicate this line. I can say 10 is greater or equal to 10. I can say 10 is less than 10, less or equal. I can say equals, and then finally not equals. Now the result of this operation right here returns a boolean. So if I run this, have a look, we get a bunch of booleans back, and we've done booleans. So here 10 is not greater than 10, 10 is greater or equal to 10, which is true. Then 10 is not less than 10, 10 is less or equal to 10, gives us true, 10 is equal to 10, and obviously 10 is not equal to 10, so this gives us false. So you can basically, so what I was saying is the result of this is a boolean. So here you could store the result. So for example, boolean, and then I'm going to say is adult, and let's say that the age is 15, and we want to know whether 15 is greater or equal to, and then 16. So this is the limit. So for you to be an adult, you have to be at least 16. And this with semicolon, and then print is adult. If I basically just add another space here, so an empty print line, and then run this, have a look, it's false in here. So this age right here, or this number, is not bigger or equal to 16. If I change to 16, this will give me true now, and anything above 16 will be true. But you see that the result now is stored within this Boolean data type. And we'll basically learn if statements later, so that this will make fully sense why we need Booleans. But for now, just know that we have these comparison operators and we can perform comparison on primitives, and more specific, numbers. If you have any questions, drop me a message. Otherwise, let's move on. Let's say that you want to increment a number other than just by 1. So how do you do it? So you saw that if I say SOUT, and if I have number 2, for example, if I say ++ and run this, you should see that we have 11, right? So number 2 currently is at 10, ++ in here, it says increment and then return the number in here. If I say ++ on this side, it returns the number first and then increments. So here ++, So this should be 10 instead of 11. But let's say that we want to basically increment this number right here by, you could say, for example, so here, int result equals 2, and then let's say number 2 plus, and then 2, right? So this now increments the number by 2 in here. So if I print the result instead here, we should have 12. So have a look, 12. But what I want to show you is that you can use a shortcut to perform things like this. So instead, what you can do is you can get rid of all of this. And now I can say number 2 plus equal, and then the increment. So here, if I say 1, you should see that if I print number 2 now instead of result, I should get 11. If I say 2 in here, I get 12. Now I could actually use this number in here, so plus equal and then this one, and this will be the same 12. But the cool thing here is that you can change this sign to say, for example, times right here. So basically take the current value of number 2 and times it by the value of number 1. So if I run this, we should get 20 there. You can also divide if you want. So you can take this and then perform a division just like that. And 10 divided by 2 is 5. You can subtract. So run it. 10 minus 2 is 8. You could also perform the modulus. So here, mod. So 10 mod 2 is going to be 0. And to be honest, this is it. Now, let me just add a comment in here so you see exactly what's going on. So here, if I just have a comment here, so let me just put this just like that. And in between, I'm going to paste something. And this is so that you have for reference. So x plus equal y is x equals to x plus y. So basically, this is what we did. So here, have a look. Number 2 modulus equal number 1 is the exact same thing as saying number 2 equals to number 2 mod and then number 1 is the exact same thing, but we're just using the shorthand. So let me just press Command Z there a couple of times, and there we go. If you have any questions on this, please do let me know. Otherwise, catch me on the next one. Before we move any further, let me teach you how to properly name your variables. So far you've seen that in here, if I have a variable called goals, so here I'm going to say int and then goals equals to and then 0. So this right here is the name of my variable. Now you can see that the way that you can name your variables, you can pretty much just do it the way you want. So here I could say G, so capital G, and then maybe capital S, for example, or L, my bad, right? So goals. So this is the name of my variable. And if I want to refer to it, I could just say SOUT and then goals in here. So capital G, goals. And if I just run this, so you see that this works. There we go. This is 0. Now, this name right here, it's not great because there is a naming convention that we should follow when picking the name of our variables. So one, your variables, they have to have a meaning behind it. So for example, if I also say foo in here, foo doesn't mean anything, right? So it doesn't represent anything. But instead, if I say goals, this now makes more sense. Instead of using capital G, O, L, S, so you can see that I'm actually starting everything in lowercase. This is the case where, so here, where the name of your variable is composed of one name. If it's composed of multiple names, i.e., let's say number of goals, for example, so number and then of goals. So I didn't teach you this, but let me just basically show you that you could say of and then goals. So right here. So this is camel case syntax, where the first word starts with lowercase, and then the beginning of the second word, so of, starts with uppercase and then followed by lowercase, and then the same for the rest of the word. So here, goals is another word, So this starts with uppercase, the rest is lowercase. So this is the recommended way for us to define our variables, and it's known as camel case. This right here is for integers. For booleans, if you have booleans, for example, so here the way that you define, so let me just say booleans. So for booleans, you kind of use, for example, is. So let me say boolean, and then is adult. So here I'm actually asking a question. Is it adult? It could be true or false right here. Or maybe we can say has. So you kind of always want to ask a question, has, and then cat, for example, true or false, right? So either use is or has for booleans. So this is mainly for variables, and then you have functions or methods and then classes, and they kind of follow the same pattern, but you'll see those throughout this course. This is all for now. Catch me on the next one. So you've learned about primitives, which allows you to store simple values. Now let's learn about strings, and then I'll show you reference types. So strings, actually it's a reference type, but it's a special one, and I will explain this later. But in here, strings allows us to store a sequence of characters, i.e. text. So if you want to store, for example, brand, so string brand equals to, and then Amigoscode. So here, let's just end this with semicolon, and this variable right here called brand has the value of Amigoscode. So this is a sequence of characters. Now here you can actually add anything. So I can add spaces, I can add gibberish if I wanted to, but basically within double quotes, so you open double quotes and end double quotes, you can put any text that you want. So this is when you want to store, for example, emails, you want to store names, any text that you can think of, you should use strings to do so. If I now say SOUT in here, I can say brand, and if I run this, have a look, you can see that we have Amigoscode in here. So this is cool. If you want to, so let's just say that we have two variables. So here I'm going to say string, and then I'm going to say amigos equals to, so this is the name of my string variable. I'm going to say amigos, and I'm going to have a second variable, and this time I'm going to say that this is code, and the contents within it, I'm going to say code. If I want to concatenate these two, so i.e. I want to concatenate amigos plus code, I can say amigos plus and then code. So with strings, the plus sign concatenates these strings together, and for primitives, remember, it adds them together. So here, if I run this, you can see that we have Amigoscode. Now what I meant was, so here, if I have 1, right, so 1 and 1, so this will be 1 plus 1, you'd expect it to be 2, but because these are strings, it's just going to concatenate these two strings together, i.e. the result will be 11. If you want to concatenate symbols, you can do it. So here I can say plus, and then here another string right here, and I'm going to say plus. So now this will show 1 plus 1. So you can see that it's not even adding these two numbers together, but instead is concatenating the strings. So this is kind of cool. Now let me just go back for a second here, and this was amigos and then code. Now the cool thing here is that with strings, if you want to, for example, let's say that you want to uppercase the result of brand. So here I can say dot, and then we have a bunch of methods available to us. So have a look, 2 lowercase, 2 uppercase, bytes, equals, substring, content, indent, index of, is empty, and split, starts with, strip, so on and so forth. So let's just say, for example, I want to uppercase everything. So uppercase, so 2 uppercase, and we're going to learn about methods later, but here, have a look. Brand, you say the name of your string or your variable, dot, 2 uppercase. Have a look at the naming convention that we've learned. And then parentheses, this is invoking the function. If I run this, you can see that Amigoscode all in uppercase. If I duplicate this and I want 2 lowercase, I can say to lowercase and run it. Have a look, all in lowercase. If I want to, let's say, get a portion of my text, I can say SOUT and then brand dot and then substring. So this is another method. And here it says the beginning index as well as the end index. So here, for example, if I wanted to just print code, for example, I need to pass 5. So here, hopefully I got this correct. Actually, no, it's meant to be 6. So 6, and now I have code because this is the 0 index, 1, 2, 3, 4, 5, 6 index. So we basically start from 6 onwards. If you want to print from 0 all the way to 5, you can say 0, comma, and then 5. So if I run this time we have Amigo. If you want Amigos, you just say 6, run it, and have a look, Amigos. If, for example, you want to check whether your string is empty, you can say SOUT. And here I'm just going to add this string like this. And let me just add a couple of spaces in there. I can say dot and then is. So remember the naming convention for booleans. So this returns true or false. So if I say is empty, if I run this, we get false. It's not empty because we've got white spaces. But if you want to check whether is blank, i.e. there is no text in between, you could say is and then blank. Now this should return true. Have a look, this is true. So if I duplicate this, and as soon as I put, for example, a letter, so A, so this is no longer blank. Have a look. So this is false now. And also it's not empty because you've seen empty means that no strings at all. If, for example, here you want to get rid of all these spaces, so let's just basically run this. So I want you to see that we have spaces at the beginning and then at the end. So 2 spaces. You can say dot and then trim. So trim will remove all trailing spaces. So if I run this, have a look. Now we got rid of the spaces from the start as well as the end. So these spaces in here. So strings are really useful for storing sequence of characters, and with them you have all of these methods that allows you to manipulate your string. If you want to concatenate strings together, use the plus, and then all of these methods here you can actually explore and see the functionality available to you. This is all for now. Catch me on the next one. In here, I'm in the official documentation for the Java specification, and it contains the documentation for the API. And you can find this link under the description of this video. So what I want you to do is type string, and the first one, java.lang.string. And what you'll see in this page is, so it says module, base, package, class is a string. So remember, we've used a string to store a sequence of characters. It gives you what a string is and what not. This is an example of how to create a string. And this is equivalent to having a character array in here. And we'll basically learn about arrays later. But for now, you can see information about how to use the string. For example, print line, how to concatenate, how to substring, so on and so forth. But more importantly, if you scroll down, in here you've got fields, constructors. Keep on scrolling down and you'll see method summary. Now this is where you find a list of all methods for the string class. So have a look. In here it says method, char at, and the description. So in here, if I scroll down, we've used 2 lowercase. There we go, 2 lowercase, and you can see that converts all of the characters in this string to lowercase using the rules of the default locale. So the same with substring. Have a look. Substring returns a string that is a substring of this string. And you've got 2 versions. So one that takes only the beginning index, and the other one that takes the beginning as well as the end index. So what I want to show you is that in this page, basically, this is where you find information about the documentation for the entire language. So we've learned about strings. And if you want to learn how strings work and the available methods, this is the place to go. And it's quite extensive. So in here, we are looking at strings, but there's a bunch of other classes, modules, and packages that you're going to see throughout this course. So as you saw with reference types, they are used to store simple values. So in here, if I have a variable called int and then age equals to, let's say 21, this is it. So you can see that it's one single value in here and nothing else. Now, when we write programs, we want to store complex values. And this is when reference types and objects come into play. So let's say that you want to store a coordinate, for example, the value for x and y. So there is a class called point in Java. So this is from java.awt, so the first one. And I'm going to show you exactly what these imports are. So if I press that, and at the very top, you can see that we have an import java.awt.star. I'm going to explain what this means later, but for now, just follow along. So this allows us to use this point class. Now I'm going to say that this is point A equals to new and then point. Now at this point, I can store the value for x. So if I press command P, have a look, it says int x and int y. So you can pass the x and y coordinates. So here, let's just say 10, comma, and then 10. Now, one thing to note is do not type x colon and then 10. Again, do not type x colon and then 10, nor y colon. So this is IntelliJ. So if I show you, so I'm going to press option and then enter. And I'm going to say do not show hints for current method, and you can see that that's gone now, but I like to show the hints, so this helps me to understand exactly what goes where. So at this point, have a look, we've got this point right here called A, and this is an object. So this point in here is an object, and I'll come back to reference types in a second, so why they are known as reference types. But in here, point A is an object, and it is because it stores more complex information. So with an integer, I can only store a number, but with this point, I can store two numbers. I can store the coordinate for x as well as the coordinate for y. So that is the main difference between reference types and primitives. Now, if I want to print the value for point A, I can say SOUT, and then you can use SOUT and then I think V. There we go. And it says point A plus and then point A. And if I run this, have a look what I get. So I've got point A and this is the value. So this is the value here. So it has this string right here, which is the fully qualified name. So it's a point that contains the value x equals to 10 and y equals to 10. So this is cool. So maybe if you want to write a game, for example, this class is kind of useful, right? So you can imagine writing the snake game. So you would use a point class. So a point allows us to store both x and y coordinates, and it's known as an object. So this right here is an object. And similarly to a string, so if I say SOUT and then point A, I can say dot. And have a look, we've got some methods available as well. So get x, get location, get y, toString equals distance. So if you want to know the distance between points, you could use this right here and some other methods. And also have a look, move. So I can move, for example, move. So maybe we've got a snake, and snake is moving from point 10 and then 11. So it's moving up. So this is how you do it. And I basically need to remove that just like that, and I don't need to print this. There we go. So if I was now to print again, so let me just duplicate this once more, run it. You can see that now we moved this point in here. So again, this is the difference between primitives and reference types. So these allows us to store more complex values. And you'll see a bunch of these examples throughout this course. So we're going to use a bunch of objects and everything should make sense. Now, let me actually dive deep into the actual difference between primitives and reference types, as well as objects, so that everything makes fully sense and how they are different. Let me explain the difference between reference types and primitives and how they are stored in memory. So before, you saw that we had this int variable age right here, and then we have a point A object. So this point A right here, it's an object. And then we did print this, and we also moved. So let me just get rid of these, so we don't need this for this video. Now, this primitive right here and this point A, which is a reference type, they are stored in memory as follows. So when we run our Java application, it looks like this in memory. So we have the stack, which is used for memory allocation and the execution of a thread. And it follows the LIFO data structure, last in, first out. And again, on data structures, we'll cover data structures and what this means. But all I want you to know is within the memory stack, we have something called a frame. Now, a frame contains all the data for one function call, and it only exists during the execution time of a function, including any references. And then we have the heap in here. So this is a space used to store objects. New objects are always created in the heap space, and references to these objects are stored in the stack memory. So let's start with the primitive that we have created. So this one, so this int age. So primitives are always stored in the stack. So i.e., when we run the program, we have a frame for the main method. So this is the main method, and inside we have a frame, and this will hold basically all of this. So for age, it will store the value in it in there. So int age equals to 21. So you can see the actual value for the primitive is stored within the stack. So primitives are used to store simple values. Then we have a point. So this point right here, which is an object. So this guy is an object, and more specific, this contains a reference to the object. So what I mean is, within the memory stack, we have a new frame for point A, and have a look. Point A now contains the following information. So it contains int x equals to 10, y equals to 10, and point A equals, have a look, this number right here, it's not the actual value for it. So this is a reference to where the object itself lives. So it's a reference to the point A. So this is the object itself. And you can see that the heap is used to store objects. Now within the stack, so point A, it's a reference. It's a reference to this object within the heap. So have a look. References to these objects are always stored in stack memory. So point A, it's a reference to the object which is stored within the heap. Now let's say that we have a second point called point B, for example. So in here, let me just duplicate this, and I'm going to say that this is point B. Now this is going to create a new frame, i.e. in the stack. So we have a frame and we have the values, so 20 and 20. Let's just reflect these. So 20 and 20. So x20, y20. And this frame contains all the data for the point B. So when we create a new object, this creates a frame. Now have a look. We have the primitives. So here, int x, the value, int y, the value, and then point B contains the memory to where the object lives. So this is a reference to somewhere in the heap that points to the object right here. So it points to the object itself. So x 20, y 20, and the same for the previous point. And to be honest, this is it. Now with a string, it works a little bit different, and we'll cover strings later. But let's say that we have a string called brand equals to Amigos, and then code. So what this going to do is within the stack is going to create the brand, and this will be equal to, you can see that it's not the value. So it's not the value. So strings also, they are references, and strings are a little bit different. But again, as I said, I will fully cover strings later, but this will refer to a place inside of the string pool within the heap, and it will refer to the string itself, Amigoscode. And to be honest, this is the difference between primitives and reference types. So with primitives, the value itself is stored within the memory stack. So have a look, we have age, and I think I actually don't need the data types in here. So let me just get rid of this. So it's much easier for you to reason about. So just like that. If you see x equals to 20 and the value is stored in here, you know that this is a primitive. So the same for a Boolean, the same for a char, the same for a double, right? So all of those are primitives. So the value for them are stored within the stack. And for objects, it stores the reference to where the object lives inside of the heap. And if it's for a string, it's a little bit different because they refer to the value within the string pool. But again, more on this later. If you have any questions on this, please let me know. But throughout this course, you're going to learn about objects and whatnot, and hopefully all of this will even make more sense. But if you have any questions, please do let me know. Otherwise, let me teach you yet another important concept, which is pass by value. Okie dokie. Now let me teach you about arrays. So far, you've seen that if we want to create a variable, so for example, int and then number, in here, we can only store one number inside. If you want to have another number, you have to create a new variable called number2, for example, equals to something else. Now, an array is a data structure, and we'll learn more about data structures later in this course, but arrays allows us to store multiple values inside of one variable. So here, you have to specify the data type, and then you put these square brackets, and then you name it. So here I'm going to say numbers equals to new, and then int. And in here, you have to specify how big is this array. So how many elements can this array hold? So here, let's say that this can have only 3 integers inside. Now, if I want to add a new integer inside, I can say numbers, and I need to add square brackets, and now I need to specify the position. So arrays indexes, they start from 0. So 0 is the first element. So here I'm going to say that at position 0, I'm going to add the number 1, and let's duplicate this. And here I'm going to say position 1, I want to add, let's say 33, and then position 2 in here, I want to add, let's say 6, for example. So now you can see how we are adding multiple numbers into this array. If I want to print the contents inside of our array, we can say SOUT, and inside I'm going to say arrays dot to string, and then pass numbers inside. So if I put this on a new line, so you see things properly. So this function here basically prints out our array, because if we print the array on its own, we'll get a random number. So here, if I run this, have a look, you can see that this is our array. So position 0, it's 1, position 1, we have 33, and position 2, we have number 6. And in total, we have 3 elements inside of our array. So if I remove that and then just print numbers, have a look, we get this gibberish. So if you want to see the contents inside of your array, you just say arrays dot to string, and at the very bottom, it does imports this, and we'll talk more about packages later, but it imports this package so that you can invoke this method, and more on methods as well. Now, let's say that we want to change. So here, I'm going to say 3. So at position 3, we want to add 6. So if I run this, this will fail. So this will throw an exception, and we're going to learn about exceptions later. But if I close this, so here we cannot access this index. So this gives us an index out of bounds because the size of our array is 3. And remember, the index starts from 0. So 0, 1, and the next one is 2, just like that. One thing to bear in mind with arrays is that once we define the size, we cannot make it bigger. So here we can only have 3 numbers, and if you want to add a 4th one, it's impossible. So here, if you want to say numbers and at index 3 equals 2, so this will be the exact same thing. So this will be arrays out of bounds. So we cannot change it. So if I delete this, and what I want to show you now is if you want to find out the length of your array, you can say SOUT and then call the array. So in our case, numbers dot and then length. If I run this, this gives us 3. So this is the size of our array. Now, if I close this, and what I want to show you is you see that in here, this is how we initialized the array. So in here, and then we added 3 numbers. But what we could do is basically on this line in here, I'm going to say int, and this is an array. I'm going to say numbers and then 2 equals 2 and then here. So at this point, curly brackets, I can specify numbers. So here 0, comma 5, and then comma 5 maybe, 6, 8, and I can add as many numbers as I want. And in here we have 1, 2, 3, 4, 5 elements inside. So if I say SOUT numbers 2 dot and then length, run this, you can see that we have 5. So this is the length of our array. So this syntax is a shorthand version of this, because here we have to specify the index. 0, we pass 1. Index 1, we pass 33. But here we can just do it in line. Then if you want to change, for example, this value in here. So this is 5. So if you want to change that, for example, to 55, you could just access the index. So numbers 2 and then at index. So that'll be 1. So 0 and then 1 equals to 55. Now what I'm going to do is just before I change that, I'm going to say SOUT and then arrays dot to string, and I'm going to pass the numbers 2, just like that. And then I'm going to duplicate this so you see the before and after. So just like that, run it, and you can see that, have a look. Before 5 was here, but then we change it to 55 and the length is 5. So this is pretty much arrays. Now you see that here we have integers, but this could be any data type that we want. So if you want a double, for example, so if you want to work with decimal numbers, you say double, and now, so nothing changes because these are still decimals. If I run it, you should see that we have 0.0. If you want to store strings, for example, so here, maybe you want to store a list of names. So string and then name, or actually names equals 2. And then here you can say Jamila, for example, and here maybe Alex. So now this array in here contains a list of names. So have a look, the data type, curly brackets, the variable equals 2, and then depending whether you initialize the array like this or as we did in here. Now this is pretty much an overview about arrays, but later we'll cover data structures in detail and you'll get to work with arrays a lot more. But for now, just remember that arrays allows you to store multiple values inside of one variable. If you have any questions, drop me a message. Otherwise, let's move on. Let me go ahead and talk to you about the null values within arrays. Previously, you saw that this is one way of initializing an array. So this array right here currently it's empty. So you saw that if you want to add, for example, a number at a particular index, you just say numbers, for example, equals 2 and then 2. So what I want to show you is if I say SOUT and then arrays dot to string and then pass numbers, I want to show you the default values for this primitive array. If I run this, I want you to see that we added position 0 or index 0. We added 2 in here. So the rest is filled with 0. So for primitives, the default value for arrays is 0. Similarly, if I say in here, so 2, and if I say 27, for example, run this. So you can see that now this is 27 and the rest is 0. So this is for primitives. Now, sometimes you might want to have the default values for your array to be a value other than 0. So in that case, what you can do is you can just say arrays dot and then fill. So you say numbers, and then what do you want to fill it with? I want to fill this array with -1. So if I run this now, have a look. So the default value now is -1, and then position 2 or index 2, we added 27. So this is for primitives. What about objects? So here, if I create a second array, and I'm going to say string array and then names equals to new and then string, and within here, I'm going to say that I want to have 2, or actually 3. So the same size as the other one. Now let me just say names, and within position 1, we're going to add Jamila. Now, if I duplicate this line in here and then bring it down, and instead of numbers, I'm going to print names in here. So now have a look. Actually, this is meant to be 3. Let's just say 3. So we have 3 slots as the one in here. But now have a look. So the default value now for objects is null, i.e. reference types, right? So here, this is null. Now, just bear in mind that whenever you are working with reference types, this is actually referring to an empty object, but I'm going to cover this later down. But all I want you to know that for primitives, the default value is 0. And for reference types, the default value is null in here. So obviously you could also go and fill the array. So here, if you want to fill that with something, so here, if I just duplicate this line, bring it right here, and then say names in here. There we go. And here I'm going to fill it with, for example, foo. If I run this, you should see that we have foo instead of null. This is pretty much everything for this video. If you have any questions, drop me a message. Otherwise, let's move on. So we've just learned about arrays, and later we'll focus more on arrays when we touch on data structures. But arrays is one of many data structures that allows us to store and manipulate data. Now, from now on, all the way to the section on data structures, we're just going to use arrays, because arrays are the building block for all other data structures. And you've seen that if we want to access an element, we need to know the index, and as we loop, if we want to get the previous or the next element, or even if we want to get the elements in reverse, then we have to use the for loop with an I, counting down, so on and so forth, right? So I'm going to use arrays for the upcoming exercises because it will teach you how to think. Instead of using lists, which you'll see later, they're much easier to work with. But for now, let's just work with arrays for the exercises and throughout the examples, because as you become more comfortable with arrays, moving forward, you will be in a better position. If you have any questions, please do let me know. Otherwise, let's carry on. So you've learned about arrays, and what I want to show you is, let's say that you want to print every single element within this array. You could say SOUT and then the name of the array, so names, and you pass the index 0. And in here, we can duplicate this a couple of times. So this would be 1, 2, and then 3. If I run this, you can see that we have James, Nadia, Sophia, and Alex. If I add an extra name, for example, Sally, and now I need to basically add another SOUT statement or print line statement. If I add more names, then I need to basically fiddle with this. Now, this is cumbersome and you should never do this. So basically from here, you saw that with loops, we can generate a number from 0 to any number, right? So what we can do instead is if I comment this out, and instead of doing that, we can use a for loop. So we say for, and we can say int I equals to 0. And we're going to keep on looping while I is less than names dot and then length. So this gives us the length of this array in here. So this will be 1, 2, 3, 4, 5. So therefore this will give us 5. So let's just leave names.length, because if we add another element in here, this will basically work out the length for us. Then here, I want to basically increment I by 1, so I++. So now that we have all of this in place, if I want to print each name, I can just say SOUT, the name of my array, which is names, and then square brackets, and inside I can just pass I. So if I run this, you can see that this still works. And the cool thing is, if I add a new name, for example, here, let's just say Aisha. And if I run this, we should see Aisha in here. Now, one thing to bear in mind is that this right here, it's very crucial. So don't say equals, because arrays index, they start from 0. So this is index 0. And let me just take this 1 and then 2, 3, 4, and then 5 in here. Now the length of this array is 6, right? So length equals to and then 6. There we go. Now if this is less or equal, then it means that at index 6 we don't have anything at index 6, and therefore this will fail in the last iteration. So if I run this, have a look, it will give us Java array index out of bounds exception, and we'll learn more about this, but have a look, index 6 out of bounds for length 6. So when looping, you have to be really careful. So this should be less, and you start from 0. Now if you want to reverse the array, you can just basically flip these values. So I'm not going to do this because I want to say you an exercise where you're going to have to reverse an array, but you've seen how to do it before. And this is pretty much it. So this is how you loop through arrays using this for loop. Let's take a break from loops and arrays, and I want to teach you how to use if statements within Java. If statements allows us to execute a block of code based on a condition, and the condition is either true or false. So if the condition is true, we execute the piece of code. Otherwise, we can tell it to execute another piece of code. So in here, if I say if, this is the command, and here I'm going to have parentheses, and I'm going to say true. So if true, I'm going to print this code runs. So if I run this, have a look, you can see that it says this code runs. If I say false and then run it, you can see that nothing gets executed because this condition is false. Therefore, it doesn't execute any piece of code that you have within the curly brackets. I can also have the else statement. So if this condition is false, I can say else. This is the default. So here I'm going to say SOUT, this code runs when false, and this is when true. So if I run this, have a look, you can see that this code runs when false. If I switch this to true in here, this piece of code will be executed. and this will not. So anything that you have within these curly brackets won't be executed. So if I run this, we should see this code runs when true. Now, bear in mind that if you have, for example, here, SOUT, and then code outside if, this piece of code in here will always execute because it's outside of the if condition, right? So if it performs this right here, and then it carries on in here, right? So if true, print this line and then carry on the execution of the program. So if I run this, have a look. So we have this code runs when true, which is this piece of code. But if I change which is this piece of code, but also have a look, code outside if, which is this line. So if I was to have, for example, SOUT and then hello as well, so this will also print. Have a look, code outside if, hello. But here, this is executed because of this line in here. But if I say false, this is no longer executed, but this condition in here. So therefore, we'll get a different result. So if I run this, you can see this code runs when false, and then we get the same result for line 11 and 12 because this is outside of the if statement. So this is the general idea of if statements. What I want to teach you next is how to use if statements with conditions. All right, now let me go ahead and teach you about packages in Java. So have a look in here. We didn't cover packages yet, and line number 1, you can see that we have a package com.amigoscode, and this was done when we did create our project. So if I open up the project tab, have a look, we have src, and then we have com.amigoscode. And then inside we have main. So this main in here is this main.java where we've been writing all of our code. Now a package is nothing but a folder that allows you to structure your application. Again, a package is a folder that allows you to structure any given project. So what I want to do is within src, I'm going to right click, and then you should have an option open in, and then Finder or Explorer if you are on Windows, I think. So Finder, and this brings up inside src, and have a look. We have com, click on it, we have Amigoscode, click on it, we have main.java. So you can see that a package is nothing else but folders. So have a look, com.amigoscode, and then main.java. In here, com.amigoscode, and then main.java. So even though that you don't see forward slashes in here, you can think of a package as a structured folder that allows us to organize our code. And within your classes, the first statement is always a package. So a class, and we'll cover more classes later, but you should see that everything that lives within this file should belong to a package. So the package name is com.amigoscode. So if I change this to, for example, without D or E, you can see that it doesn't know which package are we talking about because the name of this package is com.amigoscode. Therefore, this should also match. Next, let me go ahead and show you how to create packages. In this section, let's focus on understanding what are methods, and hopefully you'll see how we're going to start using methods from this point onwards to start building our programs. So a method is a block of code which only runs when it's invoked. We can use methods to reuse code that can be shared across the entire application. i.e., if something that you are constantly doing over and over and over again, you can just build a method and then invoke that method all the time. So I've basically gone ahead and deleted all the other packages and classes, and I only have this class called main, the one that we've been working so far. And I'm going to collapse this, and let's just look into this class in here called main. So we haven't learned about classes in detail, but here within this class, we have public static void main. So this is a method. Now, more on this method later, but when we build methods, we have to specify a few things. So here, I'm just going to have a comment for each. So the first thing that we need to specify, and if I put this as a multi-line comment, just like that. So the first thing that we need to specify is the access modifier. Then we also need to say whether the method will return, i.e. the return, and then type. Then we give it a name, so name, followed by parameters, if any, so optional parameters. And I'll show you what this means in a second. Then we need the method body, so method body, and also optional return value. So this is basically how we build methods. Now let's quickly have a look at this main method right here so that you see what all of this means. So here, access modifier, you've learned about access modifiers, i.e. public, private, protected, or default. Then we have return type. So you've learned about static. So static means that it belongs to the class. But here, void. So this right here is a return type. So let me actually say that in here. So optional, static. So here we have void, right? So void means that this method does not return anything. We have main, so this is the name of the method. Optional parameters, so here we only have one parameter and the type of it's an array. We have the method body, so the method body is anything that goes within the opening curly brackets and close curly brackets. So here, this is the body. And then we have optional return value. So since this method does not return anything, therefore, there's no return value. So this says void, meaning that it doesn't return anything. So this is the general idea. Next, let's build our own method. Let's together create a method that adds two numbers. So we want a method that adds two numbers. So here, let's just basically say private. The reason why I'm saying private is that anything that can use this method that we are about to create has to live within this class. So it doesn't have to be public. Private, static, and then here the return type for this will be an integer. So have a look. So access modifier, private, optional static, static, the return type. We want this method to return an integer. Now let's define the name. So the name can be anything that you want. So here I'm going to say add, and then we have optional parameters. So the parameters are these. So here I want this method to take an integer called number1 followed by another integer called number2. Or in fact, let me just say n1 and n2. So I can just save some space. So n2 in there. And then I need the method body. So method body goes like this. And have a look. Now I can do anything that I want. So here I can perform my business logic and then have the return value. So since this method returns an integer, I need to return an integer. So here, all I want to do is I want to create a variable. So I'm going to say int result equals to n1 plus and then n2. So I've got my result. Now I can just say return and then result. There we go. So you can see that this method here has the return because we have an integer here, and this integer is the return type. So it accepts two numbers, performs the addition, and then it returns the value. So here, if I want to return, for example, a string, I cannot do this because this method here returns only integers. But if I want to change this to a string, for example, you can see that now this works. So I want this method to return the integer result. So let's just leave it like that. Now the way we introduce this method is within our main method. This is where we've been running all of our programs. Let's just say int and then result equals to and then add. And at this point, I can pass two numbers, 10 and 10. There we go. Now I can just print to the console, result. And if I run this, we should get 20 right here. So hopefully you can see how this is coming along. So the benefit of this method is that now we can just call it as many times as you want and then pass any two given numbers. So here, let me just call this result and then 2 and then pass 100, for example. And let's also print result and then 2. So you can see how this now allows us to reuse this piece of code over and over and over again. So this is one method that basically is private. It returns an integer. This is the method, and it has two parameters in here. Now remember, static. So here, if this is not static, then it will fail. So we cannot even run this. If I try to run this, it will fail to compile. Have a look. Cannot be referenced from a static context. And that's because before, remember, I said that the only thing that can be accessed within a static context is a static instance, is a static method or attribute, or creating an instance of this class called main, and then we can invoke it. So remember, I said before, the other way is to say main equals to new main, and then here we can say main.add. So main.add, and this works. But let's not do this because we haven't learned about objects and whatnot. So let's just remove main.add from here, and let's just keep static for now. So public, or actually private static, and then int. So if you have any questions on this simple method, please let me know. Otherwise, let's carry on learning about methods. For this exercise, what I want you to do is to create a method that will calculate the rental yield. So on this website in here, I can actually, plug in some values. So let's say that my monthly rent is £1,000, and this could be dollars, it doesn't matter. And then let's say that the original price of the property is 100,000. If I calculate, you can see that the rental yield per year is 12%. Now, what is the formula? So here you've got an example. If your monthly rental income is 1,300, your annual, so you times that by 12, and then the value of the property, then what you do is you divide the total rental income per year divided by the total amount for the property. So what I want you to do is create a method that allows you to calculate rental yields. Think about the access modifier for that method. Think about the name of the method. Think about the parameters of that method, the return type, and test your method to make sure that indeed it does work. But I'll give you the solution next. Okie dokie. For this section, we're going to talk about classes and objects. You've seen that we've been using strings and other data types throughout this course, and we created objects, right? So we have the actual class, which is the blueprint. And then when we say new, and then the actual keyword, so whether it's a new string or a new date and whatnot, at that point we create a new object. Now, in programming, everything is around objects, right? So as we build code, we want to model things in the real world. So let's just take a look at this mobile phone. So this is an iPhone right here, and we can actually model this through a class. So class is the blueprint, and then from that blueprint we can create a bunch of objects, i.e. phones, right? So let's in this section first understand basically every single bit that you need to know in order for us to create a class, and we're going to focus more on models, so representing things in the real world, phones, people, cars, so on and so forth, right? So we're going to focus on that first, understand everything that we need to understand, and then later we'll learn about different types of classes, right? Because they are classes for different purposes. There are classes for us to model the real world. There are classes for us to perform the business logic. There are classes that allows us to store data, so on and so forth. Don't worry, we're going to cover step by step, but for now, let's learn about objects and classes, or classes and objects. Cool, let's carry on. As you've seen in Java, you will mainly be having a bunch of classes and then connecting them to each other. This class right here, so public class main, with this main method is a special class because it contains this main method, and you've learned about the main method. So this main method here is what the JVM looks for in order to run the application. Now, from this section onwards, I'm going to explain everything you need to know about classes, and hopefully you'll also get an exercise where you have to connect classes together and whatnot. But right now, what I want to do with you is I want to create your very first class. So let's just start with a class within this main class, but later I'll show you how to have our class in its own file. So here, let's together say class, and here I'm going to say cat. Now this class cat in here, we're going to define some properties and behaviors. So let's have a property, and here we're going to say string name. So this is the name of the cat that we want to represent. And now let's define a behavior that all classes that we instantiate from this class will have. So here we're going to say void and then meow. And for now, what I'm going to do is, so inside of this meow method, I'm going to say SOUT. And here I'm going to say name plus, and then let me just say colon, and then meow, and then 3 dots. So to be honest, this is it. So we have a class in here with one property. So this is the property. And then this right here is one behavior. So classes are made of properties and behaviors. So this is one property. This is one behavior. Now, the way I'm going to teach you classes is I'm going to teach you basically the bad way of doing things. And then I'm going to build upon it so that you understand why we do things. Right. So we have this class. Now let's try and basically use it. So here, if I say cat, and then I'm going to say cat equals to new, and then cat, just like this. So this right here is the type, and new cat is our class. So the same way that you saw with new string or integer or date, for example. So basically we are doing it for our own class, which is a cat. Now this right here doesn't work because currently we have a class inside of a class. And basically, in order for us to use this class inside of a static method as before, we have to add the keyword static, and now this works. The next thing that I want to do is I want to say cat dot, and then have a look. We have the name, but also we have the meow. So this is the field and this is the method, so the behavior. So let's just invoke this and let's run it. And you can see that we have null and then meow. So we actually are almost there, and I'm actually showing you how to do things the wrong way. But at the end of this section, you'll have a full understanding of classes. Next, let me show you why this is null. Oh my goodness, you've managed to make this far. Congratulations. So if you have any questions or anything that you didn't understand throughout this video, please comment down below, let me know, and join the private Discord and Facebook group where a bunch of other students, so we have a community of about 50,000 people, will be there to help you. As I said, there's a 20% off this course. So this course is about 24 hours. So I would say definitely go and take advantage. And yeah, I'll see you inside. Smash the like button, subscribe, and I'll catch you on the next one. Assalamu alaikum.